Hello guys, this is Prime Concept. In this video, I want to look at the sign conventions that are used in solving problems whenever we are dealing with the lenses, right? The thin lens. Now we need to learn the formula that is involved in analyzing thin lenses, the convex lens and the concave lens. But before we can learn the formula or start to apply the formula, we need to learn the sign convention that is involved there. Now, we want to look at sign convention for lenses, thin lenses actually. So what are the sign convention? So we're going to consider the convex lens first. Convex lens. Now, just like we did in our mirror studies, we used the Cartesian sign convention so that it can help us easily remember these things without cramming them. So we're going to use the Cartesian sign convention for our lenses. So since we are considering the convex lens, we're going to draw our convex lens like this. These are convex lens. So that this is our principal axis. Remember, this point is your optical center. Now remember, our convex lens is made up of two surfaces, for which this is our first surface. Now, and you notice that this first surface curves in this direction. So the first surface is going to be the actual focal length for our lens, right? So using our Cartesian coordinates, since this is the center, it simply means that anything downwards, this is our negative y-axis. Anything upwards is our positive y. Using our Cartesian, anything here is on the positive x, and anything on this side is on the negative x. So, since we want to always place our object here, it would mean that firstly, number one, this is where we would always place our objects, on the left. So objects would always be on the left, on this side. So it means that our object distance, u, is always negative, seeing that is on the negative axis. So this is a convention. It simply means that you would have to stick with this sign as long as you're following this convention. The moment you mix any two sign convention, you get a problem wrong. So if you're sticking with it, stick with this convention. U can also be positive, but that would be a different sign convention. So if you are working with this, it means that your U, object distance, would always be negative, which would mean that your object should always be on your left hand side, right? Then let's talk about the focal length before we consider the image distance. Now, since this is our first surface which would curve towards this side, it means that our focal length f would always be on this side, even though a lens has two focal points, which is here and here. But the focal point for the first surface is what we are considering. So what it means is that our focal length f is always positive because it falls on the positive side. So our focal length would always be positive, right? This is a sign convention you should stick with. Then thirdly, number 3. Now, if your image is formed on the right hand side, right, on the opposite side of your object, that is to say on the right hand side, it means it is formed on the positive side. So image will be considered to be real. While if the image is formed on the same side as your object, which is on the left hand side, the negative x, so it means that image will be considered virtual. So I'll put it down. V is if V is positive, image is real. So if your image distance V is positive, it means that you have a real image which is formed on this side. So while if V is negative, image is virtual. So these are the sign convention you need to take note of for your convex lens, right? Don't mix it. Firstly, U is always going to be negative. Second, focal length is always positive. Thirdly, if V is positive, your image is real. So when you solve a problem and you arrive at a value of V to be positive, it means that your image is real. While when you solve a problem and you arrive at V to be negative, it simply means that your image is virtual. So this is it. Now let's quickly look at that for our concave lens. I want to look at our concave lens. So for our concave lens, we'll still follow the same idea of the Cartesian coordinates. So this is going to be our concave lens. This is our concave lens, and this is our principal axis. Now, you'll notice that for your concave lens, this is your first surface, which curves in this direction. You can see it, unlike your convex. So the same way, this is my negative y, this is my positive y, this is my positive x, and this is my negative x. So anything that falls to this side falls to the negative x. Anything that falls to this side falls to the positive x. Anything facing up is positive y, facing down is negative. Now, remember, we always want to place our object on the left hand side. So this is where our object would always be. So which is on the left and negative side, right? It means that firstly, U is always negative. This is the convention. So you will notice that U for both our convex lens and our concave lens is always negative. Even when we talked about mirror, we still use the convention that U is always negative for all of them. So it's something very easy to remember. Then secondly, we want to talk about the focal length. Now you notice that this surface, this first surface, this is the second surface of this lens. This is the first. The first surface curves towards the negative direction. If you are to complete this circle, you notice that this first surface curves here. So meaning that your first focal point would be here, and invariably your focal length would be here, F, right? Now, which is on which side? On the negative side. So it means that our focal length is always negative for our concave lens. Do well to stick these conventions in your heads. Now, number 3, and because we know that the concave lens gives only one position for our image, so there's no point. So we can just summarize that by saying that for our concave lens, V is always negative, because image is always formed on the left hand side, right? V is always negative because the image is always formed on the left hand side. So V would always be negative for our concave lens, which invariably would translate to saying that image is virtual. So the image is always going to be what? Virtual. So these 3 conventions are worthy of note. U always negative, F always negative, V always what? Negative. So you can say the 3 of them are always going to be negative. So it's very easy to remember. No positive. The 3 for concave lens would always be what? Negative. So I believe this sign convention is very clear to you. If you have watched this video up till this point and you are yet to subscribe to my channel, please do well to hit the subscribe button so you'll be getting more of the contents I'll be uploading. Do well to like my videos, comment, and then share with 10 of your friends so that they can also benefit. Tell them this is Prime Concept. Thank you.